We're going to spend a lot of time talking about things that happen before fertilization, too. Conceptus means the developing offspring. You know, the fertilized egg, the embryo. Gestation period. That's from the last menstrual period until birth. However, of course, at the last menstrual period, you weren't actually pregnant. Okay. That happened 2 weeks later, as I had mentioned before. Pre-embryo. That's used to describe a developing baby from fertilization to 2 weeks. And this is where we're going to spend the most time talking about development. What happens during the first 2 weeks after the sperm fertilizes the egg? From week 3 to 8, that's called an embryo. And then fetus is 9th week through birth. When we get to the embryo stage, we'll focus mostly on how the placenta works. So in one lecture, that's basically what we can do. Here's a relative size of development from a one-cell fertilized egg all the way to a 12-week fetus. In accomplishing fertilization, let's show the female anatomy. Excuse me. Get some water. Read the question there. And think about the anatomy that, by now you should be starting to get it. Let me review the structures which I think you would have to name to answer this question. All the structures the sperm has to swim through to get to the secondary oocyte. That's the first thing. The typical site of fertilization is here, which is where? Ampulla of uterine tube. Sperm is deposited here. We call the vaginal fornix. Okay, we call this, it has to swim through external os at the cervix and the cervical canal, internal os of the cervix. This is just the uterine cavity. It's got to swim all the way through all the parts of the uterine tube here, the uterine part, isthmus, all the way to the ampulla there. And so, this is before fertilization. You got to swim through all those things. So we call some of these things, before you get to the egg, pre-fertilization events. Finding that secondary oocyte, which is, when ovulated, is viable for about a day. They say sperm is viable for about 1 to 3 days in the female reproductive tract. So for fertilization to occur, copulation, ejaculation must occur no more than 3 days before ovulation or 24 hours after ovulation. So most books will say you have about a 4-day window to fertilize within typical ovarian cycle. So fertilization is when the sperm fuses with the oocyte to form a zygote, and we'll talk about fertilization. Before that can occur, these events must happen. Sperm capacitation, sperm penetration, and then like this block the polyspermy. For a pregnancy to be successful, let one in, keep all the others out. Okay, that's the basic idea by this last point here. So let's talk about these first 2 points: capacitation, penetration. That refers to sperm head. Capacitation. Capit means head. Let's look at the sperm head again. And let me remind you of something I taught you before. The AC, the acrosomal cap. Sperm capacitation. It's a softening of the sperm head. This occurs within the female reproductive tract. It's one of the last sperm maturation things that happens. And it cannot even happen until it's in the female reproductive tract. So you're in female repro tract. By softening the sperm head, you're increasing the chance that the acrosomal cap will spill its lytic enzymes on the egg to penetrate these barriers. I'll just put that. To spill lytic chemicals contained within acrosomal cap. Onto barriers surrounding the oocyte. Now, we already know what that barrier is. I've named it before, zona pellucida. So it helps to soften the head, so you can kind of have that spillage. Let's move on. Well, here's a picture of those barriers surrounding the oocyte. So in red, I have also, in addition to the zona pellucida, the corona radiata. Barriers to sperm penetration. Corona radiata. The term means, well, corona means crown. Radiata. These are just cells from, okay, well, let's think for a second. When you ovulate, we always call it the egg. This is what you ovulate. You ovulate the oocyte with zona pellucida surrounding it, with granulosa cells surrounding that. So the zona pellucida, the eggshell, and all these cells are from the Graafian follicle. Okay. It's a barrier. There are cells that sperm have to get through. So corona radiata, granulosa cells from Graafian follicle. Now, the other thing internal to that is the zona pellucida. I'll list it again. But the thing I'd mentioned before, there are sperm receptors, specifically ZP3. There's a protein in the ZP3 that can act as a sperm receptor. But it's also a barrier. Okay, well, let's kind of move on from this. But I would like to review some of the concepts we have been talking about in terms of meiosis. Who do you think these chromosomes belong to? The sperm or the egg? See if you're awake this morning. The egg, the oocyte. The sperm got in, but this is all the DNA from the mom. Let me see if you understand this. That's the first polar body. Here, you're pulling apart the sister chromatids. So these are all singles. Half of this genetic material, let's say this half, it has to go to the sperm. The other half is ejected as what structure? Yeah, not the first polar body, but the second polar body. So that should be reviewed. So that's where we're going with this. Here's a different picture from the book. The artwork, the colors are different, but the concepts are the same. You should identify these cells as corona radiata. The white thing is not the oocyte, it's zona pellucida. Okay, but they do show the oocyte in there with a massive amount of cytoplasm. They show the first polar body. They show you arrested in. Well, they say metaphase 2. It looks, yeah, kind of metaphase, anaphase 2. It will complete once we accomplish this. This isn't fertilization. This is still pre-fertilization. They call it sperm penetration. These slides here. Okay. Sperm penetration, not fertilization. Number one, they call this approach. That's what we say right there. Aided by enzymes on its surface, the sperm cells, they weave past the granulosa cells of the corona radiata. Okay, so sperm, you breach corona radiata. The sperm head has surface enzymes to weave in between the granulosa cells. Sperm head has surface enzyme to weave past granulosa cells. Okay, so you get past that layer. Another sperm will come. Number two, they say acrosomal reaction, right there. Acrosomal reaction. I'll just kind of read this verbiage here from the author. The binding of sperm receptors in the zona pellucida causes calcium levels within the sperm to rise, triggering an acrosomal reaction. Acrosomal enzymes from many sperm digest wholes through zona pellucida and clear a path to the oocyte membrane. Okay, so they show like little balls in there. Those are supposed to be these zona pellucida sperm binding receptors, what I call ZP3. So number two, acrosomal reaction. Okay, I already lectured on the acrosome. Popular test question is on the sperm. Where did it come from in the sperm? Oh, the Golgi. Okay, it was that whole thing. So I talked about this is the reaction, the same acrosomal cap. Sperm binds ZP3. Okay, and that triggers this reaction. Let's see, how did I draw it before? So, I don't know if you remember I drew this. I drew like a sperm head, purple, and I drew the acrosome as a double green membrane filled with all these lighted chemicals. Now what's important here is the DNA in the sperm head, haploid material. But that both of these things were surrounded by a plasma membrane. Okay, and I won't draw the rest of the sperm, but that's just the sperm head right there. So what they're showing you in this acrosomal reaction is, Well, what happens when you bind the ZP3 is you have a fusion of the outer layer of the acrosome, the outer green part. Let me turn my mic down, it's kind of feeding back a little. It's okay, it's a little better. What I was saying is, you have a fusion of the plasma membrane with this outer layer of the acrosome. Okay, so maybe it looks something like, still have my nuke. Something like that, where now I use green, they're using red. These are the Lacunae chemicals. They digest, they clear a path through ZP3. Digest. Zona pellucida. So that's kind of what they show right there. I mean, it's hard to see. They do show a little bit of the cell membrane flaying out, and it's very subtle. But now you've cleared this path. We can move on from acrosomal reaction. That's important. Okay. Well, now you have this second level of species-to-species interaction. This first interaction, I should mention, this is species specific. So that triggers that first level of reaction. Now you've cleared a path. Now you have sperm that gets in. And they call it binding. The sperm's membrane binds to the oocytes, sperm binding receptors. Sperm binds oocytes receptors. So that's the second level of species specific. So you got two levels where like you bind these, you recognize the sperm, bind that, and this is important. So you get this fusion there. So force fusion. So let me read what I have. Fusion is where sperm and oocyte plasma membranes fuse. Now the sperm contents are allowed to enter the cell. Sperm / oocyte cell membranes fuse. sperm contents enter. So they show the sperm head getting in, they show microtubules from sperm flagella getting in. That doesn't matter. The sperm nucleus is what matters. Okay. So I'll write that. Sperm head enters. The last thing, step 5, for pre-fertilization events. Now that the sperm this is the fertilizing sperm. It's the winner. It got in. Okay, its genes will be passed on. Now you have blocked polysperm and keep all the other ones out. So we've accomplished the sperm penetration. We've accomplished it. Okay. So let's keep all the other ones out. You only need one sperm to fertilize. This will be the fertilizing sperm. Let me read what they have. The blocked polysperm. Oocyte, sperm binding membranes, okay, are shed. And you get the calcium level. Calcium's a second messenger. I haven't been writing it in the notes, so that's why they keep mentioning it. So the calcium levels in the oocyte's cytoplasm rise. This triggers a cortical reaction. There's an exocytosis of cortical granules, and as a result, the zona pellucida hardens, and the zona pellucida sperm binding receptors are clipped off. Okay, so that's how you block all the other ones from getting in. Harden the shell, clip off the sperm binding receptors. That's the key thing here. Block 2 polyspermy. Keep all the other sperm out because one got in from the previous step. So you trigger this, a cortical reaction. The cortical granules, they say exocytosis. That's accurate. That exocytosis, they're hardening the zona pellucida. I'll just say they burst. Hardening. Zona pellucida, that'll help keep sperm out. Hard zona pellucida, clip off sperm receptors. Clip off sperm receptors. So we've accomplished sperm penetration. Like for example, what I tried to do is interrupt the illustrations from the book with like models we have. That'll be on your lab practical. This kind of shows, there's the sperm right there. But all of these are the granulosa cells, and you should call it the corona radiata. They label it number 1, so what would you call it, the 2? Zona pellucida. Number 3 represents the oocyte. Number 4 is the ovum of the oocyte. There's the sperm. It hasn't quite gotten in yet. Okay. It's trying to accomplish sperm penetration. Well, we've accomplished it. Okay, sperm penetration done. Now let's talk about the actual fertilization. Well, I think this happens on day 14, ovulation, right? So day 14, ovulation, fertilization. You assume it happens on that day. So these are the events of fertilization. Remember, the sperm got in. Sperm head, to be specific. So it's like, okay, now what? And there's a lot of different events here. But let me read what they write. After the sperm penetrates the secondary oocyte, the oocyte completes meiosis tube, forming ovum and secondary polar body. Okay. Completes meiosis tube. So when you do that, you get the ovum and second PB. You should know what that is, polar body. Now, the ovum, that's kind of what they refer to as the female chromosomes. Now we have different models showing this. The one that we're looking at from the textbook. Keep track of everything that they show you in everything, because there are variations, and you're expected to know the variations. For example, I see corona radiata on this first picture here, but they don't show it here, and they don't show it there. I see zona pellucida, okay? I see zona pellucida, a little white thing there, and it's a little more like a blue shell there. So they do show that, and they do show first polar body and the second polar body about to be ejected. The sperm head's right there. On this model, it looks like, well, that's the tail of the winner. That's the fertilizing sperm. Is that the fertilizing sperm? No. He's knocking on the door. He didn't get in. That's the sperm head of the fertilizing sperm. There's the ovum. Okay. This one's a little different. There's the winner. He got in. There's the sperm head. And they don't show any polar bodies here. But that will be prior to the ovum forming. So this kind of looks like that. One question I always ask with this picture, this model, true or false? The sperm head has contacted the oocyte membrane. What would you say to that? True or false? Heard some people whispering. It is true, because that's zona pellucida. Number 2 is oocyte membrane. Yeah, it kind of made it. Okay, so well, let's move on. So kind of after this, you complete the meiosis tube. I still see bits of granulosa cells, corona radiata. I still see zona pellucida. I see all the polar bodies stuck inside. And you should, I think we can identify them. These two are from the first polar body. So I guess what would you call that one? Second. Okay, 1, 2 from the first, and they still call that second. Maybe just call it a polar body. I think that would be good enough. But then they show male, female, pronucleus. This is before they fuse. They say sperm and ovum nuclei swell, forming pronuclei. So I'll say sperm, oocyte, pronuclei form. So it looks like, okay, I call this N plus N. This is kind of what I've come up with to kind of help me in my head. Why do I use N plus N? Because inside there are 23 single chromosomes from the sperm head, accomplished by meiosis. Here, now we have 23 single chromosomes, haploid, haploid, but they're in one cell. So this one cell has an N plus an N. That's kind of what I want you to think about it as. Let's move on. This model doesn't quite match the picture, but we do see some things that are similar here. Now, they showed that's a polar body. That would be the first one. I believe the 4 dots mean it's already divided. So you got 2 polar bodies from the first polar body, and you're about to eject the second one. But here's the sperm head, and I've never quite figured out why they make it look like a parachute. But I believe those 2 dots represent male chromosomes. Here, they don't even show chromosomes. They just kind of show the nuclear envelope around what would you assume the 23 single chromosomes inside there. That's from sperm. That's ovum. Okay. So sperm, ovum. I rotated this picture to make it match this one here. So moving on, number 3. I'll just say pronuclei swell. Pro means before. So this is before the nucleus forms. And it looks like they're starting to approach each other. The mitotic spindle is forming between them. Remember, the mitotic spindle, that's for cell division. Mitotic spindle form. In terms of the whole N thing, it's still N plus N. You have 2 discrete structures, and they haven't fused yet. When they fuse and the chromosomes intermix, that's conception. So this is still fertilization here. We have a lot of models that show, well, not a lot, we have 2. All right, so this one here, by now, okay, let me ask you this. Do you see corona radiata in any of these images? It's gone. But in all 3, I see zona pellucida. It's still there. Okay, so this is fertilization. And let's think anatomically, where are we? Uterine tube. Okay, it's like fertilization happening on day 14. Now, I see the second polar body, and these 2 are from the first. I see this is the second polar body, and these 2 are from the first. The reason why I think that is the whole dot thing that they use, which I never quite understood. I think 2 dots, I mean, that's the second polar body. So these 4 dots are 2 polar bodies from the first one. That whole dot thing. Now, pink usually means what gender? But it isn't. It's male. Okay. So I guess this is before a time when that became a thing. Male, female. Okay. Let's go with that. See this color there? That was the male pronucleus. So I think that pinkish color, that's why they kept it here. So this model comes before that model. What you have here is a condensation of the chromosomes. That means you're getting ready for cell division. So this one comes after this one. But we're still N plus N. All right, so here is the miracle of life right here. You get zygote formation. The chromosomes with the pronuclei intermix. Fertilization is accomplished. So now we have the zygote. So zygote formation is the goal of fertilization. That's it. You know, fireworks, bells and whistles. This is it. Okay, this is the 1 cell stage. We all started off life as 1 cell. And this is it. This is the 1 cell. One cell stage of development. So now you've restored the full complement of DNA. Sperm and egg, chromosomes intermix. Once you get the chromosomes intermixing, you know, that's 2N, right? None of this N plus N stuff anymore. This is 2N. They're contained within 1 structure. Okay. Now you're ready for the first cleavage division. Okay. Do you see zona pellucida? It is still there. So the first cell divisions, this 1 cell, you cannot have 2 cells the same size because you're contained within the volume of the zona pellucida. So you have to reduce your size with each cell division. They call that cleavage. Here's a real picture of fertilization. They show them fusing there. Okay. You can even make out polar bodies in a very faint zone pellucida going around there. For us, they don't show what's going on inside. They just kind of show one cell. So what if I had you identify that? Zona pellucida. It's still there. We're still in uterine tube. Okay, that's where this is happening. All right, so this is kind of what we talked about. 4 N plus N and 2N. Now we're going to start having mitotic cleavages. So this is, day 1, post-fertilization. So fertilization, you get to their fertilization done. Now you have to develop past 1 cell. So now I'm going to start referring to the days post-fertilization. Okay. You have zygote formation. This is pretty much just 1 cell stage. You're just going to get ready for mitosis. Okay, so think, we've been talking about meiosis, been hammering you over the head with it. But mitosis is the cell division of development. Okay, meiosis was only for the development of sperm and egg, but those have gotten together now. We just talk about mitosis. And yeah, so they kind of show that, the cell getting ready for that. Let's just skip to day 2. A day later, 1 cell became 4 cells. I mean, so like for example, and this is my zona pellucida. I'll use a black shell. And you are 1 cell. Okay, 1 cell stage. One cell becomes 2, and you're contained within the zona pellucida. So you have to reduce the size. So these 2 cells that came from the 1 cell reduce their size, and they're called blastomeres. These are the first cells of development. That's 1 cell, 2 cells, blastomeres. 2 cells becomes 4 cells in day 2. Four-cell stage. Very simple. You're still confined within the volume, the strict volume of the zona pellucida. 2 cells become 4. Again, you have to reduce your size with each cell division. They call these things, these divisions, when you go from 1 to 2 to 4, mitotic cleavages. Which is, with each mitotic division, the cells reduce in size. And that's advantageous early on, and it's easier to nourish smaller cells. Okay, I think of it that way. Well, anyways, we're 2 days post-fertilization. Let's get to the 3rd day. They call this morula. The blastomeres saw a ball. not going to do every single day, but for this first couple of weeks, we do most of the days. Okay. More than that. So more than means little mulberry. You're basically just a solid ball of cells. No real structure or intelligent design. You're just basically a mass of cells. And sometimes you call this the 16 cell stage. Usually that's how many cells there are. You can also call it that. All right, 4 days. You're starting to get some organization on the inside there. They call this blastocyst at 4 days. We're still in uterine tube 4 days post-fertilization. Day 4, call it blastocyst. If you want to put an adjective to it, sometimes people call it the early blastocyst. Well, anyways, zona pellucida, it's still there, but it's starting to degenerate. Okay. Starts to degenerate. So I like how they call it hatching, okay, like an egg hatching. You're finally starting to get rid of it. But look at the inside. The blastocyst has some structure there. It's not labeled, I don't know why. These outer cells are called trophoblast cells. These inner cells are called inner mast cells, and you have a little cavity inside there. So note trophoblast cells. In development, some cells aren't actually part of the baby or what will be the baby. Some are. Some of the structures that aren't part of the baby, they usually have some kind of supportive reason. Like, for example, what we're going to see is that these will become ultimately the placenta, but it's not part of the baby. Okay. So the term that's used a lot in this lecture, in this chapter, is extra embryonic. It's not part of the embryo. It'll help it, not part of it. Okay, so the other thing I mentioned, basically these become placenta. It's more complicated than that, but essentially they become the placenta. But they're extra embryonic. Okay, but the inner mast cells, that's the embryo, embryonic cells. Inner mast cells, that's embryonic. That is baby, just a little inner mass of cells there as you hatch. So about 4 days, skip a few days to 7. Do you see zona pellucida? It's gone. That must be gone as a prerequisite so you can implant. Day 7. Day 7. Implanting blastocyst. Up until this time, the conceptus was in the uterine tube. The isthmus, I'll show you a picture later. Okay, now you're finding allowed entry into the uterine tube. So, allowed entry from the uterine tube into the uterine cavity for implantation. Allowed entry into uterine cavity for implantation. So when you're getting close to the uterine cavity, that's usually why you had that hatching a few days earlier, because you start to get exposed to the fluids of the uterine cavity, and that helped the hatching occur. Okay. So, but once you get in there, it's like you're just kind of floating around. Maybe free floating. Free floating blastocyst. But you will implant. I mean, obviously that's the goal. And so let's kind of pump the brakes a little bit. And I like this picture because it shows you what's happening in context, right? Let's look at our uterine cycle there. Hopefully you guys are studying that. I know some of you are. Well, anyways, I point to ovulation. Okay. What we talked about today is fertilization. That's supposed to occur pretty much on that day, right? We went through the events of fertilization. Then I started about talking about all the days post-fertilization. Day 1, 2, 3, 4. That's when you start to hatch. Okay, those first few days, I've read that there's contractions of the isthmus of the uterine tube. It kind of keeps you in here for a few days before you can get in there. Because why would you want to do that? You don't want to allow the conceptus in here until you've built up the secretory phase, right? Okay, so this is about implanting about 7 days later. Okay, so 7 days later is about, right in the middle of the secretory phase, which is ideal. And then first you're free floating, okay, day or two, then hopefully you implant. At around day 7, day 10, I've read, something like that. So the implantation of the blastocyst shown here. So they call this day 6 adhesion. So maybe you're free floating. So I'm going to back up a day. So to make it make sense so you don't go crazy with the days on me, let's say you're free floating day 5. Then you stick day 6. How about that? That'll make sense in your chronological head. How about that? Day 5. Free floating, floating around, bouncing around like a little beach ball or something. Then at some point, you stick to the endometrial wall. We'll call that day 6. Adhesion of blastocyst on endometrium. Endometrial wall. Well, anyways, think of it this way. You're just sticking. There's a lot of adhesion molecules on the cell surface of these structures. So we got the endometrium of the uterus, okay, and we have the blastocyst there. If you were to cut it open, what you would see is that you have this free rotation of the inner mast cells. This is about 6-7 days after fertilization. The free rotate, the inner mast cells will always rotate to face the endometrial wall. Day 6, 7 post-fertilization. Free rotation of inner mast cells base endometrium. So let's remember that the trophoblast is extraembryonic, but there's intermass cells. Pay attention to it. There's some organization that will occur. And that's embryonic. Okay. So now we start to get the actual implantation at around day 8. We call this invasion. It's basically digesting a hole inside the endometrial wall. So when we use the word implanting blastocyst, this is basically it. Things to note. The trophoblast, it differentiates into kind of two parts. Invasion, I spelled that wrong. Invasion. Trophoblast differentiates into two parts. One, cytotrophoblast. Two, syncytiotrophoblast. The cytotrophoblast, the thing to notice is the cell membranes that make up that layer, they remain intact. Cells remain intact. What I mean by that is, if you look at that purple layer of cells, each cell has a defined cell membrane. Okay, I can make out each individual cell in this layer of cells. However, this part that's doing the digesting or invading is called the syncytiotrophoblast. It really accomplishes invasion. Because this trophoblast, the cell membranes break down, all the cytoplasm fuses, and you basically have this giant blob just kind of digesting into the endometrium there. I keep misspelling invasion. Sorry. So, that word root, it means fused tissue. All the cell membranes break down, you just have this giant cytoplasm. Okay. Let's see. All right, so there are factors. Let me show it to you here. It's the yellow stuff, and they're eating its way in. They show some cells have their cell membrane, but then these, they illustrate how, well, they kind of break down. So this front edge, the leading edge of the syncytial trophoblast is doing the digesting. In this area, you'll see factors that help digest the endometrium, like tumor necrosis factor alpha. Tumor necrosis factor alpha. It's just called TNF alpha. I know your students are going to write it out for you, but things that help you not only break down the cells in the endometrium so you can get in, you're digging a hole, but also help you adhere. So there's things like cadherins. Little molecules that like Velcro, they help you stick. So you dig a hole, but you also grab onto what you're digging. Also in this area, high amounts of HCG. And I already talked about that in terms of its function as a gonadotropin. It may have some other function too, like maybe an adhering capability. But anyways, this is very important to understand. The syncytial trophoblast. You're digesting your way into the endometrium as illustrated. And I also see some other things, but are there any questions on trophoblast before I move on? So we're doing a good job here. We're 8 days post-fertilization. We're implanting, but it's like we're holding our breath, okay? Because what you must do, you gotta nick a blood vessel. You gotta dig deep enough so you nick one of those spiral arteries so the mom's blood can provide the oxygen and the nourishment to keep this thing going, okay? So like we're digging in, holding our breath. Also, we have some organization of the inner mast cells. So note that. This is called a bilaminar embryonic disc. It was just a mass of cells, but note that. Inner mast cell organizes into a bilaminar embryonic disc. Bilaminar means how many layers? 2. Let's note that, 2 layers. And the 2 layers are called epiblast, hypoblast, as indicated. Epi means overlying, it's the top layer. Some models, some books just kind of call that the superficial layer. Also known as that. So then they just call the hypoblast. Hypo means underneath. They just call that the deep layer. Also, you start to see just a tiny bubble called the amnion or the amniotic cavity. Okay. So those 2 terms, I mean, they're the same thing. They just tend to confuse students. I mean, so do you see how there's cells forming around the bubble? So they just call that the amnion, the cells that form around this little bubble. So they call the bubble the cavity, the amniotic cavity. So we start to see that form. I'll add that to the bottom here. Amnion begins to form. Eventually, it's going to surround the entire baby in a fluid-filled sac. Right now, it's just a tiny little bubble located right there. So let's move on. Let's get past this day. But I wanted to show you that this is comparable to the model we have in the classroom right here. See, this says, human germ when entering the mucus coat of uterus 7 days in the beginning of implantation. So 7 days post-fertilization, we call it 8. So it's, give or take, it's pretty good. It's pretty close. Now, I make a point of making the picture in the book look like the model. Students always think when you study the models, you're studying a different thing, but you're not. It's the exact same thing in lecture, right? It's just you didn't know your lecture notes. Maybe that's why you think it's something new. Maybe that's it. I don't know. So for example, I taught syncytial trophoblast. Now on this picture, it's right there. But could you identify it in this model? Right there. Syncytial trophoblast, this dark maroon color, and I always ask it, and a lot of people miss it. I don't know why. Syncytial trophoblast, because the colors are different? I don't know. Maybe it's hard to spell, that could be it. Okay, don't miss that one. Syncytiotrophoblasts. Well, then that's just endometrium. You're just trying to eat your way in there. I would say the pink, this layer, what would you call it, the pink layer? Yeah, I'll call it epiblast. That would be correct. And then hypoblast, epiblast, hypoblast, a little bubble there's the amnion, a little bit of amnion there. Okay. Now, we can still see cytotrophoblast maintaining its cellular boundary. And I even kind of see that here, cellular boundary, cytotrophoblast. I don't know why they change it from yellow to pink. I'm not sure why they do that. But let's move past 7 days. Okay, 1 day later, we're all in. We're completely within the endometrial wall there. So what do they call it? I don't call it anything, just call it 9 days. But we're fully implanted, is what I would say. Okay, well, what did I say the goal is? Dig deep enough to make a blood vessel. We haven't done it yet. Holding our breath for 9 days. But we're fully implanted, so we're gonna get there. Okay, so I was thinking about just trying to draw this one. I don't think I can. It's too hard. But I think the illustration is good enough to learn from. So all of this yellowish region out here, what do we call it? The syncytiotrophoblasts. So you see how it's developed? Okay, now one thing that's new is the lacuna. You want spaces in your little giant blob here as you're digesting in here, because those spaces will become filled with maternal blood. Okay, and that's what will save this thing. All right, so let's note that. Syncytiotrophoblasts. You start to see the lacuna. Now lacuna, singular, add an E, that pluralizes it. Okay, these are basically spaces. We want them to be filled with maternal blood. Spaces. We want to fill with maternal blood. You want to fill your swimming pool with water. You want to fill these spaces with maternal blood. Oh, yeah, look at that. So we have our epiblast, hypoblast thing, the bilaminar, and always keep track of the layers. It's 2 layers, it will become 3. Okay, so bilaminar. We see our developing amnion. We already noted that. Notice that cells of the amnion come from the epiblast. Let's note that. It's all the same color, right? Cells of the amnion are derived from epiblast. Okay, look at the picture. Cells of the yolk sac are derived from cells of the yolk sac are derived from hypoblast. Yeah, I think you guys can see that. Because they're all yellow, right? So they color coded for students, and it makes it easier, okay, to teach anyways. But I do want to say that the amnion and the yolk sac Those are extra embryonic. Those are supportive structures that will help development, but is not literally the baby. Okay? But they are derived from epiblast, hypoblast cells, which are the baby. And I think that's all that's new here. Let's move on, day 9. Ah, okay. So I inserted this slide to remind me. At this point of development, well, I like how they illustrate it's like two balloons. Two balloons being amnion, yolk sac. We're all in. And now you refer to the endometrium as the decidua. The decidua is the endometrium of pregnancy. So there are changes that happen. The details of that, don't worry about it. But know this, the decidua is the endometrium of pregnancy. So there are physical changes that happen when you're implanting in the endometriums. That's why you call it something different. But like, for example, that word, decidua, like when you make a decision, when you decide something between two choices, you go with one thing and the other thing falls off, goes away. You know, like deciduous leaves, those are the ones that fall off, you have to rake them. Decidua means falls off. So, you know, if you've given childbirth, you get the baby out, what comes later? What is the placenta? It's the endometrium. It's the part that's coming off with the baby. So, you know, that's kind of why they use that word. It means that which falls off. It will fall off after birth, and they literally call it the afterbirth. But right now, look what you are. You're just like a little speck of sand inside there, right? It's like that. But we can define what are called the 3 deciduas in endometrium. Okay, one is decidua capsularis. Just think of it as the endometrium or decidua that overlies the embryo. Then you have decidua basalis. Stop next to that. It's the decidua that underlies, it's underneath embryo. Okay. Then you have decidua parietalis. That's the decidua lining the rest of uterine cavity. Now, the reason why I put a star next to the decidua basalis, that will actually become the maternal part of placenta. Becomes maternal part of placenta. Now, placenta That's the lifeline between mom and baby. It's how mom will keep baby alive. It's basically a blood exchange. We'll all talk about it. But if you're going to have a blood exchange, you have to have two parts. You got to have the mom part and the baby part. So this is the mom part. I haven't mentioned the baby part yet. You got to have two parts. The term, they use the term for what it looks like, a pie, although I wouldn't eat it, all I've heard some people do. But the placenta is named for its shape. It's really, the physiology is the blood exchange between mom and baby. We'll get to that. I'm going to move on from the three deciduas. Where are we? Oh, day 12. Okay, we'll do day 12, then we'll take a break. Okay, on the ovarian cycle, what day did fertilization occur? Day 14. Now this is 12 days post-fertilization. So what day of the female cycle is that for her? 26. And when do you expect menses? 28. So we're getting to the point where it's like the female may notice she missed something. Okay, we're not quite there yet. Yeah, that's right. Okay, well, oh yeah, look, so we did it. Maternal, a sinusoid is a blood vessel, so it looks like we nicked it, and now we will start filling the lacuna space with maternal blood, but also by the uterine glands. They secrete glycogen, so a lot of blood and glycogen filling the lacuna starting around day 12. Lacuna become filled with maternal blood and glycogen from the uterine glands. The other new cells that have come up are called mesoderm cells. These are extra embryonic mesoderm. They'll help form a bunch of things like placenta, things like that. Let's just note them for now. We start to see them at day 12. See extra embryonic mesoderm. Those are those red cells. So we still have our bilaminar embryonic disc. I won't rewrite it. I'll just write things that are new. And we still have the two balloons, the amnion and the yolk sac. Okay, let's break till about, let's take a 20-minute break, around 9:05. I want to continue on with this.